Section 3.9a, Related Rates. This is example number 4. Please download the handout from Blackboard and follow along. Example number 4. Car A is traveling west at 50 miles an hour and car B is traveling north at 60 miles an hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? So I drew this picture. Here is the crossroads, and the intersection where they meet is this intersection 0.00. So car A is heading west at 50 miles an hour. Car B is heading north at 60 miles an hour. This forms a right triangle with the hypotenuse between them I'm calling Z. So this is side A, one of the legs. This is side B, one of the legs. And the distance in between them I'm going to call side Z. The given then is the derivative with respect to time of car A is equal to, now notice I've written negative 50 miles an hour. 50 miles an hour is given to us, but I've written this negative 50 miles an hour. And the reason I've chosen to do that is because at the origin, when A is to the right of the origin, heading towards the origin, it is traveling, so to speak, in a negative direction. So because of the way I chose to set up this diagram, car A is traveling in this negative direction towards the origin. That's the same true for car B. So the derivative of car B with respect to time is negative 60 miles an hour because B is traveling towards the origin in this negative direction at 60 miles an hour. The unknown is then this distance between the two, dz, with respect to time, when car A is 0.3 miles away from the origin and car B is 0.4 miles away from this origin. The relation then is the Pythagoras' theorem, z squared equals a squared plus b squared. The leg b plus squared plus the leg a squared is equal to the hypotenuse z squared. Now I differentiate, and when I differentiate z squared I get 2z times dz dt. The same with a squared, 2a dA dt. The same with b squared, 2b dB dt. Solve for the unknown and then plug in what we're given. So I solve for dz dt by dividing 2z to both sides of my equation. Down here on the bottom I calculated what z was. So z is equal to the square root of a squared plus b squared. So I plugged in a, which is 0.3. I plugged in b, which is 0.4. And that became 0.25, take its square root. Now back for my dz dt equation, I have a, which is 0.3, dA dt, which is this negative 50, plus b, which is 0.4, times dB dt, which is negative 60, all being divided by z, which is 0.25, take its square root. So the rate is negative 78 miles per hour. And that negative sign indicates to us that the vehicles are approaching each other.